Bagi Anda yang bosan membuat mobil Anda lecet setiap kali memarkirkan mobil Anda, sekarang tidak perlu repot lagi. Sekarang ada teknologi untuk memarkirkan mobil tersebut secara otomatis. Pengemudi hanya perlu mengaktifkan fitur sistem aktif park assist. Sistem ini akan memindai tempat parkir yang tersedia dengan menggunakan sensor. Kemudian memberitahukan tempat parkir hasil pindaian sensor kepada pengemudi. Layaknya cara parkir mobil, mobil ini akan memperhitungkan lintasan dan secara otomatis mengemudikan mobil ke tempat parkir secara otomatis. Pengemudi hanya perlu menginjak gas dan rem saja. Teknologi ini sudah diimplementasikan ke beberapa mobil, salah satunya adalah all new Ford Focus. Sistem pengereman otomatis. Ya, sistem ini adalah sistem keamanan mobil yang dibuat untuk mengurangi resiko kecelakaan. Sistem ini memakai bantuan radar dan terkadang juga menggunakan sensor laser untuk mendeteksi adanya kemungkinan tabrakan. Sistem ini mampu bekerja dengan berbagai macam cara. Misalnya dengan mengingatkan si pengendara dengan cara menekan rem, mengubah posisi tempat duduk, mengubah posisi bantalan kepala, mengencangkan sabuk pengaman, dan berbagai cara lain untuk meminimalisir resiko tabrakan. Misal di beberapa mobil, pada tahap pertama, sistem ini memberikan peringatan akan bahaya yang mungkin terjadi. Lampu hazard akan menyala, semua kaca dan sunroof ditutup, dan sabuk pengaman depan akan diperkencang. Pada tahap kedua, rem akan mulai diaktifkan meskipun sedikit. Peringatan cukup untuk menyadarkan si pengendara. Tahap selanjutnya, mobil akan mengalami perlambatan sekitar 3 meter per second kuadrat. Tahap keempat, mobil akan melambat sekitar 5 meter per second kuadrat, diikuti dengan pengereman penuh secara otomatis.
Welcome to the TCAS lesson in the PMDG 737 Next Generation Groundwork from Angle of Attack. So what is TCAS? TCAS stands for Traffic Alert and Collision Avoidance System. It is a system designed to identify and reduce the risk of mid-air collisions between aircraft. It provides traffic displays, alerts, and resolution advisories to the crew to improve their situational awareness and assist them in resolving a conflict. There are two principal versions of TCAS currently in commercial service: TCAS 1 and TCAS 2. TCAS 1 is designed primarily for general aviation and for small regional airliners, and it provides a traffic display and traffic advisories only. TCAS 2 is used on the majority of commercial airliners and adds several improvements over TCAS 1, most notably the ability to issue resolution advisories. The FAA mandates TCAS 2 on aircraft with more than 30 seats, or those that weigh more than 15,000 kilograms. The rules are more stringent in Europe under EASA. Currently operational on most aircraft is TCAS 2 version 7. Version 7.1 has been projected for mandate by EASA on new-build aircraft in March 2012 and for retrofit by December 2015. Version 7.1 introduces improvements designed to overcome weaknesses that failed to avert the 2002 Überlingen disaster in Germany. Studies conducted for Eurocontrol, the European Organization for the Safety of Air Navigation, indicate that the current probability of a mid-air collision in European airspace is 2.7 times 10 to the minus 8. This equates to one mid-air collision every 3 years. Implementation of TCAS 2 version 7.1 should reduce this by a factor of 4. TCAS 2 version 7 is our main focus here, however, as that is what is installed on our 737. TCAS continuously interrogates operating transponders in other aircraft to predict their positions and flight paths. It then provides traffic displays and advisories to the flight crew. A transponder is a device that automatically transmits a coded signal when interrogated by ATC ground radar or TCAS. The term transponder is short for transmitter responder, which describes its basic functionality well. Key to the content of the signal sent out by a transponder is the altitude of the aircraft. There are three main types of transponders in operation in civil aviation: Mode A, Mode C, and Mode S transponders. When Mode A transponders are interrogated by ATC ground radar or TCAS, they transmit a 4-digit squawk code. This squawk code is used by ATC to identify the aircraft. Mode C transponders also transmit a 4-digit squawk code when interrogated, but also include altitude information. This altitude information is available to both ATC and to TCAS in other aircraft. Mode S transponders include all of the functionality of Mode A and C transponders, but add many more features to the mix. Mode S adds improved accuracy, improved interrogation capabilities, and most significantly, a communication data link. This data link is used by TCAS-2 to coordinate resolution advisories between two aircraft. A Mode S transponder is therefore a requirement for a TCAS-2 installation. We will talk further about the other transponder modes and their effects on TCAS later in the lesson. So how does TCAS work? TCAS and the transponder are inherently linked. TCAS interrogates operating transponders in other aircraft, analyzes the transponder replies, and predicts the position and flight paths of those aircraft. Directional radio antennas on the top and bottom of the fuselage determine the range, bearing, and speed of the other aircraft. TCAS then computes the position and projected flight path of those aircraft. Altitude information may also be received from the other aircraft's transponder if available, and vertical speed may then be calculated. TCAS issues traffic advisories and resolution advisories as appropriate to avoid mid-air collisions. A traffic advisory, or TA, is an oral and visual alert to draw the flight crew's attention to closing traffic. Traffic advisories assist the pilot in the visual search for the intruder aircraft and prepare the pilot for a potential resolution advisory. A resolution advisory, or RA, is a recommended maneuver that will either increase or maintain the existing vertical separation from the intruder aircraft. TCAS issues an RA both orally and in the form of visual cues on the primary flight display. We will elaborate further on both traffic and resolution advisories later in the lesson. The advisory capability of TCAS is dependent on the transponder mode of the conflicting aircraft. If the transponder of a conflicting aircraft is switched off or standby, that traffic will be invisible to TCAS. TCAS only sends out Mode C and Mode S interrogations. A Mode A only capable transponder will not reply to TCAS interrogations and will therefore be invisible to TCAS. A Mode C transponder with altitude reporting selected off will reply to TCAS interrogations, however. TCAS traffic symbols and traffic advisories will be available, however resolution advisories will not be available due to the lack of altitude data. Additionally, traffic symbols on the navigation display will not display altitude. A Mode C transponder with altitude reporting selected on will reply to TCAS interrogations and will supply altitude information. Traffic symbols on the navigation display will display altitude data, and both traffic and resolution advisories will be available. Coordinated resolution advisories will not be available, however, as this feature requires the Mode S data link and TCAS-2 installation in the other aircraft. If the other aircraft has a Mode S transponder and TCAS-2 installed, then the two TCAS systems may establish communications and coordinate resolution advisories. This ensures that the two resolution advisories given will be compatible and not worsen the situation. To provide advisories, TCAS constructs a three-dimensional airspace around the aircraft where a high likelihood of traffic conflict exists. The dimensions of this airspace vary depending on the closure rate with the conflicting traffic. Traffic advisories and resolution advisories are generated based on a closest point of approach, or CPA. The closest point of approach is the point at which the separation between the two aircraft will reach a minimum value. TCAS calculates the time to reach the closest point of approach by dividing the distance by the closure rate. This is effectively a distance speed time calculation. Traffic and resolution advisories are then issued based on this time. A traffic advisory is generated when the other aircraft is approximately 40 seconds from the closest point of approach, and a resolution advisory is generated when the other aircraft is approximately 25 seconds from the closest point of approach.